There are two types of important angles inside a circle. The first type is a central angle. This angle has its vertex at the center of the circle and then has two rays extending towards the circumference of the circle. The central angle has a useful property that its angle measure is the same as the measure of what's called the intercepted arc. So for example, if this angle was 40 degrees, the central angle, then the measure of arc AC would also be 40 degrees. The other type of important angle is an inscribed angle. This angle has vertex on the edge of the circle and then has two lines extending also to the edge of the circle. This angle also has an intercepted arc from A to B. This time though, the angle is half the measure of the arc. So, for example, if angle ACB was 40 degrees, the measure of arc AB would be 80 degrees. Similarly, if you knew the measure of the arc to be 80 degrees, we would divide that by 2 to go back to what the angle is. Let's look at a first example. Here we're given both an inscribed angle, angle QRP, and also a central angle, angle QOP. And it looks like we're looking for the measure of the central angle, X. Well, I know that the inscribed angle is half of its intercepted arc, PQ. So that means that the measure of PQ is 2 times 62. So that's 124 degrees. Now the other thing I know is that a central angle has the same measure as its intercepted arc. So I already know the arc's 124, so that means that the central angle is also 124 degrees. Now let's look at a more challenging example. Now we're given what looks like 2, maybe 3 inscribed angles. 1, 2, 3. And we're actually looking for angle B. The first thing I notice is that we know the measure of angle A. That means that we know that this, let's mark it in red, intercepted arc is going to be 37 times 2. Because remember, an inscribed angle is half the measure of its intercepted arc. So that's going to be 74 degrees. The other thing to notice, and this is a little tricky, if you notice this angle right here, this angle intercepts arc AB, which is actually half of the circle, since AB, the line segment, AB, the line segment is a diameter. That means AB, the arc, has to be 180 degrees, which means this inscribed angle must be 90 degrees. Now there's a couple of ways we could solve this. We could now think that, oh hey, we have a right triangle with 37. I can just solve for this angle by subtracting everything from 180. Or I could think, oh, I have a full circle and I know this part is 74 and then this part is 180. I could solve now for this part here. I'll call it X. Personally, I think the triangle is a little bit simpler. So if you subtract, you take 180 minus 37 minus 90. You get that it is 53 degrees. Now over here, you would do 360 minus 74 minus 180. And you get 106 degrees. But then you have to remember that the inscribed angle is half the intercepted arc. So we would still get that angle B is 53 degrees.